Hello everyone. In the past few videos, we talked about describing motion and what would happen if you, say, threw your classmate off of a tower. However, this time we will be talking about the causes of these motions. Dynamics is a branch of physics that describes the causes for an object to move. For the next two videos, we will specifically be talking about forces and solving different problems with force. So what exactly is a force? Well, in general, a force is a push or a pull on an object. This push or a pull can cause motion if the object is unimpeded by anything else. It is measured in newtons, which is, when you use it for units, it's capital N, or if you're looking to be specific, it's basically kilograms times meters per second squared, and you'll see why later on. So, speaking of newtons, the most important concept regarding force comes from one Sir Isaac Newton. Essentially, he discovered what we call Newton's laws of motion. So, the first thing that he discovered is creatively named Newton's first law of motion. It states that any object in motion will stay in motion unless affected otherwise by an unbalanced force. A good way of looking at this is to think of an object that's just sitting on a table. So let's say this ball here is just chilling on a table. It's not going to move anywhere unless you use some force to move it. So let's say you push it, then it will start to move. And aside from the friction on the table, it will actually keep on moving with the same velocity that you pushed it at. So Newton's second law of motion states that the force of an object is directly proportional to the mass and the acceleration. This is just fancy for saying force is equal to mass times acceleration. And this formula here, F equals ma, is what we will be using for the majority of this on this unit for forces. So let's do an example here. Let's say a ball here, and it's a 5 kilogram ball. Let's say it's in free fall, okay? And we want to know the force at which it strikes the ground. We know that the force or the acceleration of gravity is 9.8 meters per second near the earth. Okay, so let's solve for the force at which it hits the ground. So F equals ma. F equals, what's the mass? It's 5 kilograms. Times, what's the acceleration? It's 9.8. So force equals to 49 newtons. So, as well, at any given moment, okay, this 5 kilogram ball will actually exert 49 newtons of force onto the ground. This is called weight, okay? Even when you pick it up, so let's say you pick it up, the ball still exerts 49 newtons onto the ground on top of your own personal weights on the ground, okay? So let's call this F1, and then let's call this F2, and let's solve for it. So let's say you are 100 kilograms, okay? So 100 kg. F1 would be 100 kilograms times 9.8, so that would be 980 newtons. Furthermore, now we have to find the total force of you and the ball. So F net would be 980 newtons plus 49 newtons, and that would be 1029 newtons here. So you and the ball will exert a total force of 1029 newtons onto the ground. And finally, Newton's third law is that for every exerted force, there will be an equal and opposite force exerted back at you. Okay, so let's use this example here. So So a total of 1,029 newtons is being exerted onto the ground. But at the same time, in order for the ground to support you, it has to exert a total of 1,029 newtons upwards onto you. Okay? This force is called the normal force, and it is denoted with F subscript N, normal force. This force is always going to be perpendicular to the surface you're on, and even if it's a sloped surface, the normal force will always be perpendicular. You won't have to get into this in Physics 11, but you will have to get into this into Physics 12 if you're taking that. So what are some examples of forces? Obviously the one that we talked about already in kinematics is gravity. So gravity has an acceleration of 9.8 meters per second squared near the Earth, or near the surface of the Earth. But then as you start to get away from the Earth, or if you go to a different planet, there are other calculations to be made, which we will go over in the next video. The next type of force that you should know is the normal force, which we just went over. The third type of force is the applied force. This is any deliberate force. It's typically man-made and unnatural, whereas like say gravity is natural, the normal force is natural. An applied force is always going to be like an unbalanced force that pushes an object. And this is denoted with F subscript A. The fourth type is the resistive force, or as it's better known, it's called friction. It's denoted with F subscript FR. Friction can be a lot of different things. Like on a surface, it could be like how rough the surface is. And on, like, if you're in a free fall, then friction could be the air resistance. Essentially, friction is, it's always going to oppose the applied force. Finally, we have the tension force, which is F subscript T. This is like any force that's exerted by, say, like a rope. Let's say you're pulling on a rope that's pulling a box, then that's the tension force. So let's do some examples here. So for each of these questions here, I want you to sort of draw a diagram of both the object and the forces exerted onto the object. I'll give you guys some time to think about this and to draw it out. So for those of you who drew horses, you got it wrong. Physics is an art class, and realistically all you have to do is draw a square, and for different forces you just draw arrows directed away from the box, and these arrows should be headed in the direction of the force. So like let's say you have a gravity force, okay? Then you wouldn't draw it like this, you would draw it like this. Oops. You would draw like this. So it's pointed away from the box and it's in the direction of the force. So let's go over all of these. A. This one is, so the horse is just standing on the barn. Well, you have your gravity force, and if you remember Newton's third law, for every force there is an equal and opposite force. So especially if it's on a surface like this, then the normal force Fn, and this would be Fg. B. Now, this one is tricky because just because you have velocity doesn't mean you have force. The reason for this is because if you look at F equals ma, which is the force formula, there is no variable for velocity, but there is a variable for acceleration. So if your object is not accelerating, if it's just in constant velocity, the acceleration is going to be 0. Okay, so if you went ahead and calculated all of this, it would be 0 newtons. Therefore, your free body diagram should look like this. It should be the same as the first question. Anyway, on to your third question. For the most part, it's the same as this one. It's the same as your previous question. But now we have an applied force. Simple as that. On to your fourth one, and now you have a resistive force. So resistive force, as we know, always opposes the applied force, so it goes to the left. And we denote this as FFR. Now, on to your fifth one. This is in free fall, so therefore, there's only gravity acting on it. Because there is no surface here, there is no normal force. So the only force acting on it, the only unbalanced force, is the force of gravity. Now, this sixth one is the one with the catapults. There is no force going up. I know it's because, like, you know, the catapults moves an object, but if you think about it, a catapult, it moves an object, but then the object it doesn't accelerate, it just ends up moving at a constant velocity, assuming that there is no gravity. So now that there's gravity, there's only that's the only force acting on it. And your final question, the winch question. Okay, so this is your horse, and you know that the horse is being pulled down by gravity. Okay, so then you need a tension force. So that would be your rope that's pulling it up. Because, okay, assuming that this horse is in equilibrium, which means it's not moving up or down or left or right, then it would be Ft equals Fg. So your tension force will be equal to the gravity force. So for your next question, I would like you to solve for the net force. So essentially your net force, which is denoted as F net, will be equal to F1 plus F2 and then all the way to F of n or whatever. Okay. Yeah, so solve for all of that, and the mass of your horse is going to be 150 kilograms. Think about Newton's second law, which is force equals mass times acceleration. You're given everything you need to solve for the force. So yeah, have fun. So I hope that was enough time for you guys to solve for them. If you didn't, pause the video right now and continue solving. So in this case, the horse is in equilibrium. So Fg equals Fn. Okay, so what would your net force be? It would be F net equals to Fg plus negative Fn. Why is that? Well, because Fn is opposing the gravitational force. So it doesn't matter what that is because we determine Fg equals Fn. So if you subtract some number by the same number, it's going to be 0 newtons. And this applies to the second question as well. Now, you're on to the third question. So F net equals 2, and once again your force of gravity and your normal force cancels out. So your net force is going to be simply Fa. So mass times acceleration equals to 150 times, what was it, 2? That's 300 newtons there. The fourth question is where things get tricky once again. So you don't quite know what your force of friction is because I didn't state it. What I did give you was the coefficient of friction. Now what does that even mean? It's basically some number that determines how resistive some surface is. Okay, so that's denoted with mu. So FFR is equal to mu times your normal force. So mu Fn. And we know that Fn is mass times acceleration, which means the equation for frictional force is mu times the mass times the acceleration of gravity. So if we plug in all the numbers, 0.2 times 150 times 9.8, we should get to 294 newtons. Okay, so your net force, F net, should equal to FA plus FFR. So that would be equal to, your FA is 300 newtons plus, and remember, since FFR is opposing the applied force, it's going to be negative, so negative 294 newtons. That would equal to 6 newtons in total. And don't forget units, or don't forget your directions. So that would be 6 newtons to the right. And in the case of question 3, that would be 300 newtons to the right as well. Now, on to question E. The only thing that's pulling on it is the force of gravity, so F net equals Fg. But what's Fg? Well, it's mass times the acceleration of gravity, so 150 times 9.8. And that would work out to around 1470 newtons. And that's going down. Question 6, same as above. Now we're on to question G, and this is basically the same question as question 1, right? Because Ft equals Fg, so they cancel out. So in total, it would be 0 newtons. So that's your introduction to forces. In the next video, we will start to work on more advanced problems using what you learned from this video here. Yeah, until then, I hope this has been a helpful and educational video. And yeah, I'll see you later. Bye.